So now we enter the third type of gene mutation, which is base deletion. Here, base deletion. Okay, so that is the third type. So base deletion occurs like this. So this is the DNA double helix. Okay, as the normal one. So to start the transcription, as usual, the DNA must be open, and mRNA is produced. So this mRNA is produced after the transcription process. Okay. So this is the sequence that is complementary with the DNA sequence, this one. Okay. So this mRNA will undergo translation. This mRNA will undergo translation where the first codon CGG will produce arginine. Second codon UAC, tyrosine, GAG, glutamic acid, and UUA, leucine, and for example, CUA is serine. Okay. This is the normal polypeptide chain. Okay, but if mutation occurs, okay, so for example base deletion, where it occurs in the DNA template. So as you can see, this is a DNA template, but mutation occurs. For example, base deletion, where we delete one base, for example T, okay, and this will cause a shift on the codon behind the point of deletion. So that is the point of deletion. Behind it, it will shift forward. Okay. So when this when this DNA undergo transcription, so it will produce the sequence is also different. The first one is still the same, GCC, produce this complementary base. ATG, UAC, same. But this one, CCA, will produce GGU, okay, because the base DNA have been deleted T, okay, and the rest is also different. So UAC and UAC. So after this mRNA sequence undergo translation, the amino acid produced is arginine, same. Tyrosine is still the same, but instead of glutamic acid from GAG just now, it will produce glycine. GGU produce glycine, and the second one, the fourth codon. So UAC, instead of leucine, it will produce tyrosine. And the last one is UAC. Instead of serine, it produces tyrosine. So as you can see, the amino acid now is different from the point of mutation. So before that, arginine, tyrosine, glutamic acid, leucine, and serine. Now it is arginine, tyrosine, glycine, tyrosine, and tyrosine. So from the point of mutation, the amino acid sequence are changed. So this is a serious effect to the person who occurs this mutation. Will cause frame shift mutation. Okay, so if we delete 3, just now we delete T only, one base sequence. But now if we delete 3 base sequence. So for example, the normal one, this is the normal one, we back to normal. Okay. But for this DNA, occurs mutation, but we delete 3 bases. So for example, we delete CTC. Okay, so I'm going to cut this TSC. We delete, caused by a mutation. Okay. So as you can see, CTC has been removed. 3 bases has been removed. Okay, so now the bases behind the point of deletion will also shifted forward. So it will cause frame shift mutation. And when this new sequence of DNA undergo transcription, it will produce mRNA that also have different amino acid, different bases sequence. So this one, the sequence is now the sequence is now CGG is the same, okay. UAC is the same, but now the new sequence is UUA, okay, because we removed already just now 3 bases, and the fourth codon is CUA, okay. Right, so now this mRNA will undergo translation, so produce same thing, arginine. This one CGG, arginine, UAC, tyrosine. But originally, it's glutamic, right? From GAG. But now, UUA will produce leucine. Okay? And the the fourth codon, CUA, will produce serine. So as you can see, the glutamic acid, one glutamic acid is removed from this polypeptide chain. Okay, but from the amino acid sequence behind the point of mutation is still the same, still leucine and serine. There's no changes. Only one amino acid is removed. So compared to the first one has more serious effect because it will change all the amino acid behind the point of mutation. But for if we remove 3 or 6 or 9 bases, it will not change the amino acid sequence from the point of mutation because still the same, leucine and serine. Only one we remove. Okay.